Hello everyone, my name is Akanksha Arun Wagmare. Currently, I am studying in Sri Siddheshwar Women's College of Engineering, Solapur with CSC branch in TY. Today, I am explaining one of the point in ML, that is machine learning. The point is support vector machine. In support vector machine, we have to learn here that is the introduction part, their types and how SVM works. Support vector machine. Support vector machine or SVM is one of the most popular supervised machine learning algorithm which is used for classification as well as regression problems. The first one is the supervised machine learning algorithm. The supervised machine learning algorithm means in which input data is labeled. That is called supervised machine learning algorithm. Next point is it is used for problem classification problem in machine learning. The main goal of SVM algorithm is to create the baseline or decision boundary that can be segregate n-dimensional space. That is used for face detection, image classification, and text categorization, etc. The main goal of SVM is to create a baseline. Next slide. In next slide, there can be multiple lines or boundaries to segregate the classes in n-dimensional space. But we need to find out the best decision boundary that helps to classify the data points. This best boundary is known as hyperplane. I show the one example is below. This example, see first this example. In this example, the two different classes are present. One is for star and second is circles. This to separate this data, we use a one hyperplane or one straight line. That line is called hyperplane. In the second example, I can draw two hyperplanes. Which one? And I have decided that which one I want to decide that which one hyperplane is the best hyperplane. So for that, we can go to the next slide. That is the dimension of the hyperplane depends on the features present in the dataset. Which means if there are two features as shown in the image, previous image, this is one feature and this is another feature. If two features are present, then we have to separate that features with the help of straight line. That is, hyperplane will be a straight line. And if there are three features, then hyperplane will be a two-dimensional plane. We always create a hyperplane that has a maximum margin, which means the maximum distance between the data points. The data points or vectors that are the closest to the hyperplane and which affect the position of the hyperplane are termed as support vectors. Data points or vectors that are closest to the hyperplane. That data points are called support vectors. See, there are two types of SVM. One is linear SVM and another is a non-linear SVM. First is a linear SVM. Linear SVM is used for linearly separable data. That means if a dataset can be classified into two classes by using a single straight line, such data is termed as a linear separable data, and classifier is used to call as linear SVM classifier. The linear SVM, the main point in linear SVM is that the data which is separable with the help of straight line, that is called linear SVM. Um, See, this is an example of linear SVM. In this x1 and x2 lines, two data is present. One is circle and another is star. I can draw here two hyperplanes. But which hyperplane is the best hyperplane? For that, we can draw here, for a big hyperplane, we can draw G1, and one is a positive hyperplane and another is a negative hyperplane. Also for D hyperplane, also we can draw one positive hyperplane and one negative hyperplane. We have to calculate the maximum margin in between two hyperplanes, and which one has a maximum margin, we can select that hyperplane is the best hyperplane. And the data points which are closest to the hyperplane, that points are called support vectors. Next, this is a diagram of linear SVM. In that, this dotted line is a hyperplane, and this is a positive hyperplane, and this one is a negative hyperplane. The distance between negative hyperplane and hyperplane is 1, and also the distance between hyperplane and positive hyperplane is also 1. Along with that, this is a line, that is w into x plus b equals to 0. This is the equation of hyperplane, and w into x plus b equals to 1 is the equation of positive hyperplane, as similar to negative hyperplane equation is w into x plus b equals to -1. And we have to calculate linear SVM, that is 2 upon cardinality of w. This slide is the non-linear SVM. In that, if data is linearly arranged, then we can separate it by using a straight line. But for non-linear data, we cannot draw a single straight line for separate data. So to separate this data point, we need to add one more dimension. That is 3 dimension, and we calculate that dimension by using this equation, that is z equals to x square plus y square. See this figure. In this figure, two types of data. One is triangle and another is circle. But this data we can't separate by using a single straight line. So for that we use the next slide. In this we see, using this three-dimensional, we separate this data. Circles are come near to 0, and other triangles go in upper side, and for that we can, after this, we can draw a best hyperplane. So due to this we can easily separate this data set. This is all about SVM and their types. Thank you for watching this video.